Okay, so I brought them over quick before you could really investigate them. This is one of our shapes, and this is another shape.
Cool.
So pick one.
Let's look at this one.
Okay, so just you can move it around, just try to keep it in camera.
So this one looks like the V shape we were talking about for x plus y squared. Z equals x plus y squared.
Okay, z equals x plus y squared.
Well, this doesn't make a lot of sense here because we're still going to be getting lines.
Like the lines get shorter.
But there's still lines like x plus y equals 10 is still a line just like x plus y equals 0 is down here.
Okay.
So I didn't think that these would be getting shorter like this.
Ah, okay. So something surprising is happening. Actually, this is going to be a good surprise
Also,
to try to explain to you.
And also this, it looks like a parabola.
So it like curves down suddenly. Here.
That might just be a little miniature flaw in the printing, but actually I'm not sure if that curves. What do you think? Is it a straight line? Let's look at it kind of in the camera.
This here is a curve.
Yeah, around the outside is a curve, but did you mean it curved here? Like right at the edge?
No,
So I think that's a straight line.
That's a straight line, right?
It's a straight line.
That'd be the
That's a
line
straight line.
x plus y equals 0.
Alright. But yeah, it is a little mysterious because it did seem like we were gonna not get it getting thinner going up to the top, so
We just keep
Not-
getting some thickness.
not immediately clear why that's happening, although maybe I'll help you guess why in a second. Alright, so what about this one?
This is our x squared plus y squared.
Oh, we thought we were going to get like circles going up, but we thought we were going to get like a parabola. You have these like spikes coming out.
Oh, here I think I can understand why we have these weird spikes.
Okay, why?
Because we're only looking at a small portion of it. We're looking at like a 4x4 cube. Looking at the lines from we're looking at from -2 to 2 in all three directions.
Well, we were looking from x going -2 to 2 and y going -2 to 2 and letting z be whatever z was.
Like, I think here, maybe this is between -2 and 2, you can see the complete circles.
Uh-huh.
But then here, as it gets above -2, the circles are past, parts of the circles are out of that range now.
Yeah, so let's bring this back here and I'll draw in some squares.
Circles.
Well, both actually. So we have some circles that stay on the inside, but your intuition is exactly right. We also have circles that go like this.
Where only the parts of them are showing.
Right, we're only seeing little bits of those circles. Bring that shape back in.
And then
So
that,
we're only seeing parts of those circles.
Eventually it just gets outside the range.
Yeah, so you would, if I had printed this differently, you would see these connecting with each other. In fact, this here is the point, or these go out to the point 2, 2. So that is square root of 8.
Yeah.
So all these 4 points at the tip are part of a circle whose radius is the square root of 8. But this should help you understand this graph that we have here, or this square should help you understand this shape now, what's going
well
on.
then, again, the lines are moving farther out, so less and less of them can be seen. Here you can see the full length from this point to this point here. And then as you're moving out, the lines move closer and closer to the opposite diagonals.
Uh-huh.
Therefore, you're seeing less and less and less of them.
Yeah.
Very good. Very good. And the other interesting thing is these are printed to the same scale. So this was x plus y squared, right? So this was the point 2, 2. So x plus y squared here, x plus y is 4. This squared is 16. Here on this one, this was x squared plus y squared, so 4 plus 4 is 8. So this is half as high. So these are the same scale, right?
Yeah.
So this is actually what these look like compared to each other.
Cool.
So when you see these equations, if you accidentally think that x squared plus y squared equals x plus y squared,
You're wrong.
well, it's not that you're wrong, you're just confusing this shape and this shape. And I wanted you to see that these shapes don't look anything like
Yeah.
each other.
So that's why they're equal.
Yeah, they're not equal. Pretty cool, huh? I thought this was a neat use of our 3D printer.
Yeah.
All right, good job, hun.